our basically sequence that we started a long time ago here. When we started this course, we said that this is an ethical hacking course, and in ethical hacking, what you do, you start with reconnaissance, and then once you finish the reconnaissance, you go for scanning, and once you finish the scanning, you have something called vulnerability scanning. Once you finish the vulnerability scanning, you do for enumeration, and once you do the enumeration, we talked about password cracking. So password cracking here we have covered already, okay? And then if you really able to gain access, that's fine. If you are not able to gain access using enumeration and password cracking, so try to exploit the systems. So exploitation and Windows buffer overflow is in the stage of gaining access. So today we'll cover Windows buffer overflow, and later on maybe tomorrow we'll be covering exploits. And once you exploited the machine, guys, you need to do something called Windows or privilege escalation. So this lecture is specifically about privilege escalation. So what we will do this week, we will looking at Windows buffer overflow. We're looking about what we mean by exploit and the framework for exploitation. And we will also cover what we will do is the sky is the limits. And once you become an admin, a root, or maybe a domain admin, you can do a lot of stuff. You can do antivirus evasion, or you can even disable the firewall, or you can install more applications in the system and compromise more system. You can do a lot of post exploitation, or you can add or create a backdoors. So I think here is I would say the topics are really need to be a little bit arranged. So we'll be covering the topics here, but in a really different arrangement. This is the whole idea that I wanted to show you these guys. And again, here is our website. If you guys allow me, I'm sorry. This is gonna be I don't know where is the buffer overflow, but I'm gonna show you here. Okay, this is the reading chapters of Coding Dojo of the buffer overflow. So you guys also, if you wanted to read it from here, but I have already prepared a nice lecture for it. So if you guys wanted, I can share it with you. Okay, so this is basically the buffer overflow. Um, Again, this is the topic. I would highly recommend you guys to read also here as much as they can. And also I will share with you guys the lecture as well. Okay. Okay, so let's go ahead and start the topic for today. Okay, before the starting, I wanted you guys to raise your hand so Abir can really take the attendance. And then once we are done with the attendance, I'm gonna go ahead. Abrar, can you raise your hand? It's nice to see you, Abrar, after a long time. Okay. Shahid, so everyone is raised his hand. So again, guys, the way that I wanted to explain Windows buffer overflow, I'm gonna take it very simple, and I'm gonna then introduce really a bit complicated topic. So I'm gonna take it very simple in the beginning, and then we will take it a little bit further. Okay, but before we go to the buffer overflow, I just wanted you guys to remember that we are in the course of ethical hacking. Okay, and ethical hacking does have a methodology, and this methodology basically is what we have discussed so many times before, that we need to really follow a certain methodology. Either we follow the Lockheed Martin methodology, which is kill chain, or we either to follow the CEH, which is basically certified ethical hacking stages, the 5 stages. Whatever is the stages is the same. Okay, it is always start with reconnaissance, and then scanning the target, and then exploiting the target. And then once we exploit the target, we can try to maintain access and have privilege access. And then once we have done this, we will have covering tracks. And that is exactly what I'm covering in these two basic parts. get your foot in the door means steal password file to run dictionary attacks, try to guess a password online. So this is kind of gaining access. This is what it's saying. Get your foot in the door means have compromise some machine there. Okay, sniff password of the network. This is all kind of password attacks that we have explained in a earlier version, which is basically an aerial lectures. We talked about there is offline and online password attacks. There is also non-technical password attacks, and all of them at the end of the day is will allow you to have some sort of access to a system. Okay. Also, you need to look at the web vulnerability. We have already explained one of the web vulnerabilities, and we said web is very famous, guys, because web is usually is where your presence on the online. So let's say that you are a bank, okay, and you decided to really do online financial business. The first thing the attacker will look at is your basically your bank website. So make sure that all the vulnerability that we have discussed in the OWASP top 10 or in the previous lectures, you already understand how it is, how it works, and how to mitigate it. Okay, one thing is that it allow us to mitigate it is to use vulnerability scanner and using exploitation techniques to really mitigate these attacks. Okay, use partial access to gain root admin access. What we mean that the attacker, once they have access to a machine, they will try to do something called privilege escalation. We will explain privilege escalation maybe in 2 days, and we will explain some techniques that will allow you to have a privilege account. So sometimes once you exploit the machine, you will look for another vulnerability to exploit again to become a root. So you double basically exploitation. One exploitation basically to have a normal access to one of the application or one of the vulnerability that exists. And once you are there, you try to exploit another vulnerability to become a root. And sometimes, guys, it requires you a third vulnerability to exploit to become a domain admin. So if you manage to exploit 3 vulnerabilities, then you will own the domain. And this is where is really dangerous. If someone managed to exploit the systems in a 3 different ways and has root or domain admin, this is really bad for the organization because now they can do whatever they want. The easiest thing they can do is to spread a ransom attack within the organization and hold all your data really hostage to them. Okay, so this is the first, this is where we are right now. Okay, guys. Step to break in, we have already done this. Okay, set up a way to return back. This is means that we creating a backdoor. Once we are admin on this machine, I will create a backdoor, and even I will close the vulnerabilities that I found and allowed me to have an access to this machine. Why? Because I don't want anyone to use it. So, and I wanted really to have a full control over this machine, and I wanted to come back whenever I want. So this is where you set up and maintaining the access. And basically maintaining access means I'm creating backdoors, I'm creating a command and control center to control this machine, and this machine will be reporting to this command and control. So this is what he means by set up a way to return. This is a maintaining access. And then also you need to make sure that you don't really get caught in early beginning or after exploitation, because we mentioned that we have defensive techniques and we have detection techniques. So the detection technique, guys, will be looking for something anomaly happening in the network. And if they are really well trained, they will really see what you are trying to do in the background, or adding some service, or adding some, registry keys and all the stuff. So the attacker will try to do what? To really delete the logs, create fake logs, or even mislead the detection teams so they will not be able to detect him. Okay. And then finally, you can work on action of objectives. This is why you have done this, why you really attacked this machine in the early beginning, and what was the reason behind this attack. This is where the action on objectives is happening. And this is where the attacker will really achieve his objective of the hacking. So maybe he wanted really to spread a ransomware. Maybe he wanted to spy on you. Maybe he wanted really to steal some data or exfiltrate data outside. So this is where it happens here, that it's action of objectives. Okay, guys. So this is just like a quick reminder for the stages of ethical hacking. Again, why you need to remember these stages? Because for two reasons. For interview reasons. So you can really be asked in any one of these stages, and they will ask you what do you do in these stages. So every single steps of what I have already explained does have a specific methodology to do. So for example, if we talk about reconnaissance, we have passive reconnaissance, we have active reconnaissance, and the passive reconnaissance, we do certain things. In the active reconnaissance, we do certain things. The scanning, it also has certain methodology, and this certain methodology have a certain ways. We look for the live host. Thank you, Abdihal. And we look for certain, I would say, ports, certain service running, certain vulnerability with the scanning, and then we also look at the gaining access. Gaining access also does have certain methodology. We try to crack password. We try to find vulnerability in the operating systems. We're trying to find vulnerability in the application runs on the operating system. We're trying to find vulnerabilities in the web application. So all of these guys are certain methodologies that we followed, and it can be a question in the interview. Also, why we learn all this stuff? Because long time back, I have given you a lecture about something, how to really kill the attack chain or the kill chain. What we mean by this, that if we understand every stage and we understand every single move the attacker will do to exploit our networks, we will able to add defensive layers and detection layer in each stage to detect if something anomaly or something abnormal happening, and this is will make the attacker life is much harder to really attack. So if I know that the attacker can guess the password, and can they use dictionary attacks, and can they use brute force attacks, maybe I will apply lookout policy, or maybe I will make my password is more complex, or maybe I will add multi-factor authentication. So this is all what we have learned here. It can be looked at as a career for you if you wanted to be penetration testing. So we're teaching you the main basic skills that will allow you to do this, or we can look at from the defensive perspective. And defensive perspectives means I wanted to understand each stage so I can really build my defenses accordingly and fortify my network so no one can really reach. Okay, so yes, this is just a quick reminder for what's happening here. So here, buffer overflow. Okay, so why attackers will attack will do buffer overflow? So this is really important, and I have already added here, guys. Later on in this chapters is basically here is why the attacker will attack really a buffer overflow. Why? Because currently, guys, we have so many firewalls. Okay, let's say this is our IT systems. I'm just gonna explain why the attacker is interesting to do buffer overflows first, okay? Or maybe web application attacks, or maybe inject some code to your SQL, or why they are not really into our network really attacks right now. So we mentioned that any IT system consists of network, okay, operating systems, okay, and application running into the operating system application. So the buffer overflow is basically is targeting application. Why it's targeting application, guys? Because basically in the last few years, we have already implemented so many techniques to really stop the attack in the network level. So if we have firewall, we can stop certain traffic to get in, and certain traffic cannot be getting in from the network perspective. Okay, we have IDS, IBS that can monitor for certain signature or certain traffic that's going on, so it can really detect if there is some attacks happening. Okay, we have web application firewalls that can really detect this. Okay, but our application, guys, it will allow the attacker to access the application over a certain port, and the firewall and the application firewall will, and the IDS will not complain. Once he attack a certain application, guys, what will happen is it will allow him to really inject some code inside this application and see how this application will react. So, and this is why the attacker is becoming really more interesting about application level attacks. Why? Because basically we have fortified our network in a really good way, but our application, because it's written in, I would say, a weak way, or I would say with an old programming language, it still allows the attacker, okay, to really attack the application. Okay, and if we have an old application running in our machines or our computers or our network or our servers, it's easy for them to attack this application and take control over the application. It's easier than attack the operating system and the network. But again, I'm not saying the operating system and network is 100% secure. There is still there's still vulnerability there, but not as the application in the sorry, not as vulnerability in the application. Why? Because we have so many applications running in our environment right now, and that's why we mentioned in so many occasions that we need a white listing for all these applications. So we only wanted to allow certain applications to be listed. So in here, this is what he is discussing here, saying in the current firewall-based reality of today IT world, the wily hacker can no longer employ username and password brute force attacks or attempt to log in interactively, يعني using telnet or SSH, as the system will most likely deny external access. Okay, especially if you're coming from the internet and you're trying to SSH to a box inside, okay, it will not work. Okay, as such, in this case, hacker now turn to attack application and service. And that's why I told you the attacker is just really interesting with your web application. Okay, your any application that you run, your DNS, your mail server, and if you have seen most of the attacks that's happening in inside the world right now, it's target a lot of application. Okay, or your operating system. So you target application and service, which is the firewall will not protect. Example, the mere FTP www. Okay, one of the attacks that it can be done here, and it can really be, I would say, headache for people is overflow. So let's go and try to explain overflow in a very simple term. So overflow, okay, means if you let's look at this. If you have a jar and you keep adding water here to this jar, it will overflow. Why? Because I added more water than this jar can contain, right? So if this jar is 1 liter or 2 liters, and I put 2 liters and a half, what will happen? It will overflow water outside of the jar, right? Or outside of this basically containers, right? And again, and that's exactly why we look at here. If I have a registry here or a buffer or a memory in the address, okay, or sorry, or memory location, okay, and let's say the capacity here, guys, okay, is only 5 characters or 5 digits. What will happen here is the first digit will go here, the second digit will go here, the third, the fourth, the fifth is here. But what if I try to inject the number 6 over here? What will happen? We will have the overflow condition. That this buffer or this memory location, okay, was meant to store only 5 digits, but in the matter of fact, the attacker add 6 digits, okay? And that is the 6 digit over here is overflow because it doesn't really has any any place in this buffer. So this is one thing. So what he's saying here, guys, it's saying again, there's a very common software vulnerabilities right now, and I explain why it become very popular right now to look at the buffer overflow is basically because a lot of vulnerability that exists is basically application. So you have issues with input validation, you have buffer overflow, that's what we'll discuss today. You have format string problems, you have integer overflow, you have race condition, maybe we talked about it before, but this is the definition, okay? So the definition is I have a container or a memory space, and I'm trying to add more what this memory space can handle. Okay, this is the condition. let's move here. I know some of you guys will really hate programming, but for me, I think programming is fun, and especially if you try to understand what programming is all about, you find it is very fun. So what we have, so Reem is saying it's fun. I agree with you, Reem. It's fun, especially if you understand. If you don't understand, if you try to memorize code, then it will not work. So let's look at this, guys. So this is a function, okay? It's called foo, okay? And this function will accept some characters, okay? And this characters is gonna be s, okay? So this function is gonna be accepting characters, okay? And why this function, guys, looks funny a little bit? Because it's written in C, okay? I know most of you guys, when you studied in university, you didn't really have C programming. I know some of you when it's I agree with Nasiba when it's work. I know that most of you have studied Java or Python, but this is a little bit old programming. And this old programming, the C and C sharp and C++, is used to be the common programming language for a long time. Okay, what we have seen in Java and Python, all this stuff, is just new programming language. So most of our application, a lot of our application, I would say, it's written with C and C++. Okay, guys? So let's look at this. It defines here, okay, another variable, and this variable, guys, is called buff, okay, and it specifies the data type here is character. So before the variable in C, yes, exactly, like an array. It's an array, I agree, but I don't want to say array and big words right now. This here is an array or a container for 10 characters, okay? And the buffer and array and memory space is all the same, by the way, okay? And I'll explain what is array on the right time, but I'm just trying to simplify. So here we have a variable or a list of data, okay? It contains 10 spaces, and the data type here is gonna be characters, okay, guys? Characters like A, B, C, D, all the way to Z, okay? I have a nice function here, and this function is doing what? Are doing something called string copy. Okay, what is a string copy means? A string copy at a function in C that will allow you to copy a source to a destination. Okay, guys, what we mean by this, you have this S over here as a variable. You can copy it and put it in the buff, which is a list of characters or an array. Okay, if you guys are happy with array, that's okay. Okay, guys. And then you print off buff is, and then the S also variable. Okay, so this is very simple code, which is really taking from the users some data and then save this data in a container or in an array. Okay, and then this function, if you guys understand it, I can go for calling this function. When we call the function, we wanted this function to do something, okay? So in here, I'm gonna add this string over here in this function, okay? So when I call the function, there's something called instruction pointer in our memory. If you never heard about instruction pointer, the instruction pointer is something. Once you finish this line of code, it will tell. Once it see foo, it will say, you know what? I have foo, and foo. This is a function. I'm gonna go execute the commands in foo. So, okay. So foo now will be loaded with this is string is too long for foo, so I will add this here, and then I will create the buff, okay, and then I will execute this specific function. And what will happen here, guys? All this code, okay, is gonna go to where? Is gonna go to my 10 digits or 10 characters array, okay? So can you imagine how big it is one? This one is super big compared to this 10 characters. It's definitely more than 10 characters, right? Okay, I don't know how it is exactly, but I can tell it's maybe 20 characters. So what will happen is the first 10 characters will be written here, and the rest, guys, okay, it will be written of and doing the condition of overflow. Okay, guys, and I will see, I will show you what will happen if you write something like this and you have a compiler in your Windows. So if you install Windows compiler and you have something like this, what will happen is, guys, it will crash and it will show you this an overflow condition has already happened. Okay, so again, this is the same exact example that I was telling you. If I have 5 spaces here as a buffer and I tried to add 8 character, okay, so what will happen is the 5 early beginning places will be filled, okay, and where is the rest here? It will be written somewhere. Okay, this is interesting. Why interesting, guys? Because our memory, okay, let's say this is our memory, okay, when we have a memory here, okay, and you try to add some more memory or some more data, what it will written, it will be written in the next location. Okay, usually the next location, guys, does have important data. So what happens if you write here over this important data, okay, and especially if this important data is actually telling your executable program to do something, the program will crash. Why? Because this is, I once you written here, I cannot, I cannot really execute what is being written here, and the program cannot really jump one steps to the next step to execute because he doesn't understand what is written here, and it doesn't make sense for him to jump one steps. So what happens is when you add more data than it can handle, it will corrupt the next line of data, or it's an important data. And this important data, what will happen is when it's corrupted, the program will crash and you will get the condition of overflow condition. Okay, guys? If you wanted to see how it looks like, I have like a small diagram here to show you if I added more data than it's the things will handle, we'll get out something like this. Okay, look at this. This is a created program that is keep really adding more data that your buffer can handle or your array can handle. And once you reach a certain condition, you get this error message: stock overflow.exe has stopped working, and the program will crash. And then you will see this is start happening until and then you have to cancel and close this program in order really to be back. Okay, and this is still happening right now if you created this condition that I have. So your program can crash if I really added more data. So everyone understand what is the problem here in this small code over here? Okay, guys, do you understand why the program will crash? Because you basically writing in different memory location, and this is will corrupt the program flow and it will crash. Okay, great. So how can I stop this? Okay, I know this is very early to talk about, but really, how can I stop this? Okay, I have a buffer or array, as you guys saw. So I have Ghazwa, so coding errors are typically the cause of buffer overflow. It is basically, I will explain how to stop it, and I will explain to you what is main issue here. The main issue is I really created an array or buffer, and then I didn't really check how many data has been entered to this buffer. Okay, this is the main issue. Okay, so I tell you this buffer is 10, and then I allowed the user to add 20. Okay, so it corrupted my program. So it's somehow, it's our responsibility as a programmer or as a software developer to really make sure that to really run within a certain limits of my array of my buffer. Okay, so let's look at this, guys. So this is why do buffer overflow happens. I explain to you guys. What is the solution for this? And the solution for this, guys, is basically we do something called runtime bound checking. Okay, what is a runtime bound checking? It means every time you start to fill this array or fill this space in the memory or fill this buffer with data, we will have something called it bound checking. Okay, when you enter number 4, it will say the array now is filled with 2 locations, and now there is 2 spaces left. Okay, when you fill it with another 2, it will say the space level or space left is 0. When you try to add number 8 and saying, so sorry, this is out of bound condition is happening and you cannot add more. So this is what we called it the runtime bound checking. It will check every time you fill this. If you have the programming language doing the run bound checking, it's good because you don't have to write it by yourself. Okay, guys? Otherwise, you need to do your own run bound checking. So we understand how we can solve this issue of buffer overflow. Okay, but does it exist in every single language? No. Okay, so here the runtime bound checking, guys, is by default in Java and Python. So this is the new programming language, guys. It do the runtime, so you never have this in Java or Python. Why? Because it's already included. Every time you create an array or a buffer or a space, it will really check how many characters has been filled. And if you're trying to run more, it will give you an error. Sorry, we cannot run. Why? Because we have the runtime bound checking. Okay, anytime, an hour. Okay, but again, here, guys, in C and C sharps, it doesn't have. So you really need to create your own runtime bound checking. There is another solution to do this. We'll talk about it later. Okay, but this is the basics stuff. Okay, so we have the pros of the Java and Python that we will never have a buffer overflow. Why? Because this is included in the Pythons and in Java programming language. Okay, but it comes with cons. Cons means when I implement this in C and C sharp, because they don't have this runtime bound checking, it will really impact my performance and the time of execution of the program, because every time I'm creating an array or a buffer, I need to check when it's been filled. So it can really, impact my execution time and my performance. Okay, so this is the difference and how really. If you wanted really a simple explanation for runtime bound checking, guys, is you remember, if I don't know if you have played bowling before. Okay, in this bowling, guys, we have this small I would say boundary here. Okay, it will, even if you are really, this is first time, right, and you are really horrible in this, even though that sometimes it's the first time, it's a good time. Okay, so if you really throw it in a really bad way, it will never allow you to go to the second track or the next track. So it will keep your data within the array. Anything, even if you really completely try to fill the buffer with something to overflow it, it will not work, because you have this small barrier here. It will bounce back until it reaches to the ball, or it's gonna go in this small tray until it goes out, and it will never jump to someone except if you are really aiming to do this. Okay, guys? So this is the runtime checking, a simple example to really explain what is it. Okay, great. So let's look at, guys, what is the issue here. But still the issue is, it's not a big deal, because, the program is corrupted, and really, it's okay. It's a program crashed. What is the really big deal here? Okay, so the big deal here is, which I wanted really to explain, is usually when you fill this with data, and this data is really executed in the next space of memory, it's really corrupting something called the return address. Okay, so what we mean by the return address, guys? The return address here, every time you have a line of code, okay, when you finish this line of code, there is another line of code to be executed, and there is also something called pointer to that. It's really managed to tell you what is the next line of code to execute. So if you call a function, this function will be called in a different area in the program. It will be executed, and then there is something called return address. Why? The return address will take you back to the normal main program. I'm gonna try to explain this in an easier way. Okay. So usually when we write programming, in order to make our programming more readable and easier, we write something called the main code, okay, or the main function. Okay, that's why in a lot of times when you write a programming in Java or in maybe Python, you start with the main function, and then under the main function, you will have some small function here to do some other stuff, and this function you write it somewhere else in the code. And every time you come here, this specific function will be executed. And in order to execute it, once he sees the name of the function, he goes and calls this function. This function will be executed, and then it will return back to the main program. Again, if you never heard about this stuff, if you never heard programming, how to do programming in this way, that's fine. Okay. But what I wanted to do is our program are really done in a specific way that we always return to the main function and execute. So what happened here? Let's say that the attacker really managed to add here something to control the returning point, okay? And instead of here returning here to a certain point where it's normal procedures of the program, he returned to an address where he add some code. What do you think what will happen? Again, if this is a bit too much, I'll explain it one more time. Again, so I have always main function and some small function here to do extra stuff. If you wanted to see an example, let's say that I have a main function here, and this main function, guys, will say integer x, okay, is 5. I'm sorry, guys. I didn't want to teach this in Sarah's day. 6, okay, and then we have multiply, okay, or maybe we have integer z, you know, 7, okay, and we have another main function here. We mention here multiply this is xyz, and this is d, and multiply x y z. Okay, guys, and we have a function here called multiply, and this multiply does have the following stuff. Multiply is saying, you know, x multiplied by y multiplied by z. Okay, return, for example, m. So this a program, guys. I know that some of you have done in the university when you used to do calculator. So you have your main function, and then you have all the other function in calculator is written in a different area. So the multiplication will be done here, the addition will be done here, the subtraction is going to be done here. Even, you know, divide is going to be done in somewhere else. Okay, and every time the main function will call one of these functionality to do a certain functionality. Okay, so every time you see multiply, or the user will enter x these numbers, it will go and ask for the multiplication. It will do the multiplication, and it will return back to the main function to print out the results. So this is a very simple calculator problem. Okay, so what I was trying to say here, guys, once you've done a multiplication here, what will happen is you always return back to the main, right? Okay, you always return back to the main and continue the instruction written in the main. Okay, so this is what we call, when we return to the main, we call it the return address. Okay, what if the attacker managed in this case, okay, when he filled, let's say that you asked him, the attacker, to add 4 digits, he add 9 digits. And instead of 9 digits, he managed to manipulate this return address to the main function to another area of the code where he injected some code. what will happen in this case, guys? Okay, so if he managed to play with the return address to the main function to another area of code where he added some code, this code will be executed. And that is exactly why we are really worried about these kind of attacks. Because if the attacker really managed to play with the return address, right, and he really sent the instruction code to another area of memory where he add his own code, okay, this code will be executed instead of what? Of the normal procedures of your main function. Okay, guys? And that's why returning address is very important for the attacker. And that's later on we'll see in the class that when he manipulated the return address, he can really direct this code to an area in the memory where he can execute a specific command or specific, we call it shell code. And this is another definition that we'll talk about it. And this shell code will do something for the attacker. And this is where the exploitation happening. So if you guys allow me to jump here a little bit, okay? And in the previous example, guys, here, okay, I will explain also what is the stack is, because the stack is also important. So I'm gonna explain what is the stack. So here, the return address usually goes to the parent function, okay? And if it didn't go to if he added some rubbish here, and you cannot really return to the parent function, your program will crash. I have explained this. Why? Because we have an instruction to do in our programming, especially if we're programming without object-oriented. We have to follow a certain instruction, certain steps. So if I really modify the return address for a function, okay, what will happen? And we cannot really go to our parent function, where the program will crash. Okay, but this is really doesn't really what the attacker wants, because crashing programs can cause denial of service, but he doesn't really want the denial of service. What he wanted to have a control over your code. So the returning address, guys, he wanted to control. How he wanted to control? He wanted to really change the returning address to an address in your memory, okay, where he control and add a specific code to execute. So again, what I mean by this, let's say this is your code, okay? You done some certain operation here, and you were supposed to go to your main function to continue the instruction here, because the instruction mean integer x, integer y, z equal x z y, and all this stuff, right? So the return address has been changed from going back to the main function to another area of the code of the memory. What will happen in this other area of the memory? He wrote something specifically, and once he wrote it, it will be executed, and once it's executed, it will be executed with the privilege of this application. So if this application, guys, are running as a root, you will have this code will be executed as a root. Okay, so if you wanted to have a CMD or a shell or maybe a bash from your Linux systems, you will get it. Again, I'm gonna take it one to one and to explain how this is works. Just give me 1 second. So let's move here. Okay, so in the return address, he add to able to really add a specific address, where this specific address contains his code. So what will happen is usually the instruction here saying go to this address. So I will go to this address. When I go to this address, I will find the code that's been injected by the attacker. It will be executed, and the attacker will have some code that he injected earlier in this, basically because you know what happened? The attacker will, he will do here? He will say, you know what? I wanted really to, I'm gonna just explain this, just focus with me a little bit, guys. So here, okay, this is the memory. Okay, our memory is, for simplicity, it looks like this. Okay, so let's say that attacker is being given the chance to, you know what, to enter data here. So he will enter some data here. Okay, this is the data he will enter here. And this data also, okay, it will overflow in here, in this area. Okay, it will corrupt the data here. If it corrupt the data, the program crash. But what the attacker will do is say, you know what, instead of crashing this, should be a returning address to somewhere here. How about if I return an address to here, and in this area, I will inject certain code to be executed. If he managed to really direct your program to go to a certain area controlled by him and inject the code in this area will be executed. Instead of what? Instead of your normal program instructions. Okay, guys? So this space, it used to go to here to your main function to continue execution, because the main function called giving 4 multiplied by 6, he add a certain code. So out the multiplication results, he managed to say, you know what, don't go to the main function, go to certain area in the code where I added my code. And this is where exactly, will be executed. How the attacker can know the address? This is very good. Says he doesn't know the address. He need to be very smart in this, and I will explain how he will be smart in this. Just give me one space. First of all, he doesn't know your program, and he doesn't know your addresses, but he knows that your program is vulnerable for buffer overflow. So we will talk about how the attacker will manage really to override some area of your address until he reaches an area he can execute the code. But just for now, let's take it gradual. But very good question, Ustaz Anwar. Okay, so we understand what is we mean by return address here, guys. And the return address means we should go to the main function or to the main part of the program to execute more. No, he managed to manipulate this area, okay, to go to an area where he has his own code to be executed. Okay, guys, this is I'm just gonna give you a simple example. I know this is not really valid in a lot of cases, but it's just to make it easy to understand. Okay, so let's look. If we go to an ATM machine, what happens usually in ATM machine, we will have our ATM machine guys asking us to enter some numbers. Okay, it's saying enter 4 digits number, right? Let's think about it. If I enter 6 numbers and or 8 numbers, or even if I enter 20 numbers, okay, usually I should have a checking for how many numbers I have entered. And if I have a buffer only for 4 digits, I should only accept 4 digits. It's again back to which programming language I used to really develop the software for the ATM. Okay, but what if I manage really to add certain code in this area or certain format for data? So when it's really executed, it takes me to right away without even checking my password right or wrong, and then it takes me to dispense money or to allow me to withdraw money. Now it takes me to an area where it execute withdraw money, and it will ask me for the amount I want. Okay, what will happen? The attacker will just put 10,000, and this 10,000 will be out. Again, I'm just giving you what can really buffer overflow do, because buffer overflow, what it will do, it should ask you for 4 digit or 5 digits, password, but there is no checking. So you added, you know what? You added 10 digits, but in the 10 digits here, it really manipulated the address to go right away, not to check your password is right or no. No, the returning address go to the withdraw money right away. Once you get the withdraw, what will happen? The attacker will add money or will add the amount he wants, and this money will go out. Okay, again, what we mean by here it is the programming is going sequentials. Sequential means line of codes. Sometimes there's a function called. This function, it checks the account bin, okay? So the attacker add his account bin. It's definitely wrong because he doesn't know what is the bin is, but he noticed that, okay, it accepts from him more than 4. So he said, you know what? Let me try to add more and more and more and more and more. Okay, I don't really know where is the dispense money, but I will try until one of them reach to the address of the this dispense money or withdraw money. And once it's been executed, it will ask me for the amount, and then I will get the screen saying, you know what, you can withdraw 100 or 200 or 300 or 400 or 500. I will hit the amount and then I can enter. I get this money back. Okay, but again, the issue is that the overflow happened, and then where exactly this dispense money exists in the memory, so I can really write the return address to go to the dispense money right away. This is the Nawar question, and this is what I will explain later when we are. He doesn't know, but he will try. Okay, so I hope this is a little bit making sense. This is very close to what happened in reality. Okay, guys. So what will attacker will do when he injects some code in your application? What he will do? He will write a code here. What this code will allow him? He can read the a certain file in the application. He can dump the password if he managed to really access your ATC password. He can dump it. Okay. He can start a shell, and shell means I'm giving him the command line. He can write whatever he wants. So what we mean by this? We mean that, okay, the attacker managed to add some data here, and he managed to really override the return address. And when he managed to really change the return address, he say, you know what? Go to this part of the code and on behalf execute CMD, okay, or execute bin.ch. When he execute the bin.ch, now the attacker, instead, then the program, instead of showing the next part of the instruction, he will execute CMD or B or SH, and the attacker now can see the command line in his screen. Okay, so this is how you manipulate or control the return address. And that's why return address is important. I will show you guys how the return address will looks like in a bit, because I don't want you to be confused. But this is again, what is the buffer overflow can allow him to do. Usually they like to have a shell, because once he has a shell in his hand, he can really write whatever he wants. He can start to grab data about you. He can bring around, start to maybe dump hashes and all this stuff. So this is what the attacker will like to do. When he returns the address, he returns it to a part of the memory that's owned or controlled by the attacker, and it will execute a certain shell. Okay, maybe you say, guys, this is the buffer overflow. Is something was really a long time ago when we used to have C and C sharps. No, we still have a lot of buffer overflow. So this is over here, guys. You know, it's basically a part of the vulnerability, which is basically the CVE that we talked about, CVE, common vulnerability and exploitation. Okay, and this is in 2021. This is a list of a buffer overflow in different applications. So we still having this again because we relate for a long time in C and C++ programming language. It's Java and all the stuff. It's fairly new programming language. Okay. So in order to understand really and wrap your head around how memory can be manipulated and how memory in our computer works, so I added some slides here. I know it's like a really easy slides, but it shows you how our programs are handled in the memory. This is very important. So we have something called stack and heap. And what is the difference between stack and heap? I will explain in 1 second, but I will take this from a bit earlier than this. If you have a program you written in maybe C++ or C sharp, or maybe you write it in Java. Okay, what happens when you write this program, guys? You write it with your IDE. So you know the IDE or SDK's software development kit, or the IDE, which is basically something like Eclipse or something like IntelliJ. So you write this code. When you write this code, guys, and hit run, it will compile this code. Why it's compiling? Why we need compiling? because our English or the language that we wrote the code with, it's really the computer doesn't understand. Okay, it's the computer does understand only one and zeros. So when you give him high-end programming language, you need to turn it to a machine language or something code he understand, which is one and zero. And that's why we need compiler. Some programming language, like I would say JavaScript, it uses interpreter, but this is something else. But here we are saying compiler will take this English and will turn it to a code. So this is a machine code. That's it's one and zeros, okay? And this is why we need a compiler. So when we get this data, okay, or we get this machine language, what we're gonna do with it? This is where we start to really save it in our memory. Which memory we have? We need to execute the program, right? So which memory you have in our computer, guys? We have the random access memory. But the random access memory, which is the RAM, is divided to three or sometimes 4 areas. And I'll explain what is the difference between these areas. Let's just jump a little bit here. Okay, we can see this is the machine level code will be saved in a memory area within your basically your computer or your laptop or whatever the tools that you use to program this language. Sometimes you are using, for example, IoT device to do this. So it will save it in the memory area. Okay, the generation machine level code will get loaded. This is called the loading part. We load these codes into the memory. Okay, how we load this code in the memory? As I mentioned, that your memory is divided to 3 areas, and each area of your memory will get portion of this code. So you have the code instructions will be in one area. You have the statics, especially if you used a static function, will be saved in one area. Okay, if you have local variable, it will be saved in one area. If you have object and reference to object, it will be saved in one area. Okay, I know this is maybe you have something studied, but again, I'm just explaining it for the first time. First time you hear this. Okay, so the memory area is the random access memory, and the area, the RAM memory region, is used to run programs and is divided into 3 segments. This is in some computers architect, it uses 3 segments, and some other computer architect, it uses 4 segments. And I don't know if you have ever looked at the memory, how it looks like, but this is how it looks like. This is your memory when it's basically divided. It's divided to a machine code, stack, and heap. Okay, and what is the difference between stack and heap and machine code? So the machine code, this is gonna be saved here. This is your instructions basically. So what is the difference between stack and heap and how it's being used? So I got you guys this diagram. I know maybe you have seen this before, but when you write a program like this, public methods or public function, you will have something called local variables. This is local to this specific function. And you will have something, sometimes you're using object oriented. So in object oriented, we use classes, and we do something called initialization for classes. So if you never heard about object oriented, or you never do any initialization for a class or anything, that's okay. But all I wanted to say, there's a difference between the stack and heap, because our local variables is going to be stored the way it is in a memory address within the stack. Yeah, exactly. It is the way that we store data. Exactly. So the local, but they are stored in a different 2 location. So the code and the instruction will be in the code function area. The stack will have the local variable, and it will have something called the object reference. So the object reference is gonna really refer you to a part of heap where the object is really initiated and the data for object is there. Okay, why is this, guys? Because usually stack is really static and it doesn't really grow, and the heap can really grow. So you can create million objects. Okay, if you put it in the stack will be full, and it's gonna destroy your memory. So you have an area in the memory where you can create more object and more data can be really stored there. So it's more dynamic. So the heap is a little bit more dynamic than the stack. So this is how. Okay, and this is, guys, again, what is the difference? The stack will have the reference, and the reference will really show you where is this data is going to be shared in the heap. Okay, guys, do you understand now what is the difference? Three area. Some computer architect will add an area, another area. It's called static area, and this is especially if you are running a static function. Uh, Also, again, if you never use the static function and know what is the static function, that's fine. You will have an area for static function in the memory. So this is just I'm showing you this because later on we will use this in our inshallah explanation. So we have the stack, and you can see it's already we're storing the data here. Okay, guys. So this is a simple explanation, okay, for what I have explained to you. This is the stack memory. Okay, and when you have two, if you guys can see here, I have the main function, and the main function, it will integer x, it will take a variable called x, variable called y, and also a variable called m, but m will call a function called multiply. This is the example that I was trying to explain to you guys. It will multiply x and y, and then it will print out or print f tamam m, and then return to 0. Okay, what happened is, guys, the main function always comes here. This is the first early thing that is going to be loaded in your stack, and also any local variable, it will be here. Okay, guys. So this is how the memory stacks works. It will take the memory, okay, and it will add it here, okay. And once we in this program is executed, it will call the multiply. The multiply is basically a function that accepts two integers, n1 and n2. And what it's going to do with this two integers, it's going to basically, guys, multiply n1 and n2 and return the amount, and this amount will be saved in m, and again it will print out m. If you guys can see, once we loaded the main, when we call the multiply will be loaded, and also the local variable here n1 and n2 will be loaded in the stack as well. Okay, guys, so we seen how this works. Okay, clear? Okay, so let's move a little bit and also try to explain also that according to what type of I would say, I mean, I'm sure that you have studied something like this in the university. When we call integer x, how many bytes in the memory we are using to store x? Okay, this is according to the programming language. So some programming language, we say integer is going to be allowed to store in 4 bytes. You know, characters, string, it will be around, you know, float is going to be stored in 8 bytes. So what I have added here, guys, for you is just saying that sometimes when we use certain, I would say, data types, these data types will be allocated different type of bytes in the memory. So here's the memory address. Okay, if I have, for example, variable name is called num, okay, it will save for num 2 bytes here, or 2 address spaces, okay, to add memory addresses. Okay, if I have character, which is C, it will only save 1 byte for this character, and it will shows you that it's saved in this memory address. Okay, if we are looking at the float over here, the integer is going to be here. Okay, float is salary, is going to save 4 bytes for or 4 bytes for basically for the float. So again, it's according to which programming language you deal with. It will assign every time you assign certain, I would say, data types, it will say, you know what, the memory space or the number of bytes that I will save for this specific types is gonna be 4 bytes, 2 bytes, bytes, 4 bytes. This is also something you really need to know. Okay, so let's guys look at this small example for Stack Overflow. Okay, so let's try to figure out what's happening here. So first of all, I have an integer. Sorry, I have a main function, and then main function is gonna be loaded where in the early beginning of the stack, because the stack is being filled this way from down to up. And again, how to fill the stacks is incremental or decremental or all this stuff. This is according to which processors you are using and how it handles the instruction when it's being used. But again, this is not the point that I'm trying to say here. But again, the integer main will be firstly loaded here, and then every time fun will be called, okay, fun will be called here, and we have fun and accept integers. And if a is equal to 0, then we return, okay? Otherwise, I will add to a1, okay, and then what? I will print new line, and I will print if the a and function a. So what I will have here, guys, so this is basically like a loop, okay? And this loop in the early beginning, guys, it will say, you know what, fun 5, okay? So when I call fun 5, my function over here will be called to this specific function, right, guys? Okay, so if a equal to 0, return. Returns mean go to the main function. But is it a equal to 0 in this case, guys? No. What will happen is it will add 1 to a. So this is going to be a is what? Is 6. Okay, and then print out if a, so it will print out, for example, 6 here, and then it will call fun a. What is the a equivalent now? 6. So it will
It's a
go again.
recursion. It's a recursion function, so it will load it until the program crash.
Crash, exactly. So it will keep doing this recursions over and over. And a is not equal to 6, so it will do the same exact thing here, and it will go doing keep and doing adding and go into loop, and will never goes back to this main function. And you can see integer fun is being called, integer fun is being called, integer fun is being called, until all your memory, guys, stack will be full with this function running, and you will have memory overflow. Okay, guys, do you understand how this works? Okay, and that's why I told you, if you run this function in your computer and you have a compiler, you will get this is being increased, and it's gonna fill the memory space until you get the stack overflow. Why? Because this is gonna run for what, forever if you live it, and that's why you get this, guys. Okay, again, what I have explained to you, this is becoming famous right now because the attacks in firewall and network is not very common right now. So the attacker now, they shifted their attentions to really basically application, and application, especially one of these application are that is programmed using basically the C and C++. Okay, so what is the definition of buffer overflow? طبعا this is all history of buffer overflow, and this is the definition of really proper buffer overflow. I think right now we are comfortable to understand the concept a little bit. No, DLL injection happens in the basically DLL injection when we do privilege escalation. Okay, but the buffer overflow will allow the first exploitation for the system. But maybe later on I use buffer overflow to really cause another exploitation. But for now, we do usually DLL injection to have higher privilege in the system. Yes, happen in C and C++, mostly. Yes. Okay, so a buffer overflow, guys, also known as a buffer overrun, is defined by NIST as a condition at an interface under which more input can be placed into a buffer or data holding area than the capacity allocated. So what we mean by this, I have a capacity of 10 characters. I added 12 characters to this character. So this is the condition that happened. It's overwriting other information. So we overwriting the next return address. And when we overwriting, basically the program will crash. But what the attacker will do, the attacker will exploit such a condition to crash a system or to insert specifically crafted code that allows them to gain control over the system. So this is basically the definition of NIST. We have already seen it in reality or in examples how it looks like. But I really have, guys, a more, I would say, advanced examples, which is, again, this is how the stacks looks like in computer. It's a part of the code, part of the static global function is going to be loaded here, part of the stack and part of the heap. And this is basically how the stacks looks, how our memory are divided to a location. And you can see here, guys, the stack have a limited space, while the heap is more dynamically, see, it's like a free store. And that's why we have a reference here. And our object in object-oriented programming is all living in the heap over here. But this is not the examples that I wanted really to show you guys. So the example I wanted to show you guys is basically this example. This is the example that I will take to explain how object-oriented is happening here. So let's look at this, guys. We have a main function here. This is our main function, okay? And this main function will call a function and 1, 2, 3. So what function 1, 2, 3 means, it will call the function, which is this function, and it will give for the integer a and integer b and integer c, 3 integer value 1, 2, 3. And then we have in this function, which is, I would say, it's a sub function from the main. It has a character called buffer 5. So I'm gonna create an array which is have 5 spaces, and I will create another array which is has 10 places. Okay. So again, how this is going to be saved in the memory and how this code, when it runs, can really lead to a buffer overflow. So let's look at this diagram, guys. So usually, guys, when I load this, it will be loaded here, okay? And I will have a return address, okay? And then the function will be going to execute this function here, okay? And this all local variable will be saved here, okay? And then the program will be executed. So let me just show you how the memory looks like. So this is how the memory looks like, guys, okay? So first of all, let's start with the addresses and the stored data. How did he get this stored data? From our main function. So the main function has 3 integers, 3, 2, 1, to start from the last one and here. And if you guys look at this, you remember when I told you, according to the programming language, each one of these data types will have a number of memory bytes to store. You can see here in this example, guys, that it is stored the integer here in 4 memory spaces. And here, I told you there is something called incremental stack and decremental stack. We can see this is a decremental stack. It starts with 1000 and going all the way to 997. Why? Because I have 1000, 999, 998, and 997. So this is 4 byte addresses. It's being allocated to one integer from this function. Okay, guys?
Yes, Mr. Shadi.
Okay, guys, it's clear? Okay. Now, 2 is the same thing, 4 bytes. 1 is the same thing. And then again, we have the return address, okay, is also 4 bytes. What is the return address? Is after we finish, we call this function, it will be calling this function. I need to come back here to execute whatever here, okay, maybe to print or to do. So we have something called the return address. It's written here, as you can see, okay? And we have something called stored frame pointer. We'll explain it later on. And when we go to this function over here, this function has 2 buffers, okay? These buffers are local to this function. This buffer, one of them are 5, so I'm saving 5 bytes here. And as you can see, from 980 all the way to 976. Again, I have buffer 2 does have 10 addresses. So I'm gonna save 10 bytes for this buffer 2 from 975 to 966. Okay, guys? So we understand now how these small functions are saved in the stack. Again, I'm only looking at the stack right now because I have local variables, and this local variable does have certain spaces, and I'm not using any object-oriented programming, so I'm really not looking at the heap right now, okay? But there is heap overflow, but we are not talking about it now because we're not discussing object-oriented. So let's go and talk a little bit about this diagram, okay, guys? So if I said print out X buffer 2, what it's gonna do, guys, here is interesting. Why? When you say print of X, when you say the X, it will print out, you know, the memory location that's for buffer 2. Okay, so the memory location to start from 9966 and it's for 10 characters. So I can tell, okay, how many memory spaces and the memory addresses for this specific buffer. Okay, guys? Do you agree?
Yes, I agree.
Okay, so from 966 all the way to 975, okay, it will go here. So 966, 968. Okay, let's look at this one. So I'm gonna move a little bit here. Okay, I'm gonna print off buffer 10. Okay, sorry, buffer 2. It's gonna be 966. If I print out if and buffer 2 10, the 10 location, it's gonna print out 976. Why? Because it's gonna count from 966 all the way to 976. If it's really printed out to 976, you know what will mean? This is gonna be this buffer. If I added 10 character or more, it will be writing on the area space of buffer 1. And this is what will cause a condition of a buffer overflow. So again, buffer 2 consists of 10 spaces, okay? And this 10 spaces is really started from 966 all the way to 975, okay? If I really try to write something above this, it will be really allocated in the buffer 1, okay? And the buffer 1, if I manage to add more characters here until I reach to buffer 1, it means I overwrited the data that's in buffer 1. And again, it shows here how the buffer 1 is started. And this is a condition of overflow, how it happens in the programs. So let's see how the attacker will use this for his own benefits, guys. Okay, so he mentioned here it's an area in buffer 1, therefore buffer 2 10, which is equal to buffer 1 0. This is a buffer overflow, especially if someone managed to write something in the last bytes of 10 and it exceeded to buffer 1, the 0 addresses here, guys, which is the 0 address. What he mean by the 0 address? The buffer is when you doing an array, the array usually start with the location 0 and goes 1, 2, 3, 4. So this is the area of a buffer. It starts with index 0. So that's why he means by buffer 210 is basically buffer 1, 0. Okay, guys. So again, what he means here, when we look at here, guys, usually buffer 2, okay, should be maximum here 9. Why? Because I start from 0 all the way to 9. This will give me 10 spaces. Okay? But if I said 10, okay, this is mean number 10. Okay? Number 10 is not part of buffer 2. It's part of buffer 1. So if I manage to inject anything in a number 10 and the program here doesn't complain, means I am buffering overflow. Okay, so this is what we mean. So the buffering 10 is equal to buffer 10, and that's why the buffer 10 is 976. Okay, do you guys understand? I'm not sure if you have seen array before. Let me show you something.
Yes, it's clear.
I don't know if you guys let me show you a very important thing. Google array index addresses. Okay, so we go for images. So here, guys, if you can see, this is the array. It starts with A0. Okay, 1, 2, 3, 4, 6. So this is 3 element and 3 element 6. If I said integer 6, okay, this is one dimensional array with 6 elements. This is how it looks like. This is how I created A6. So it will create 6 spaces, but this 6 spaces started with 0. So if I wanted to print 7, it will be something out of these 6. It will be printing out the element number 7. Element number 7 is basically part of another characters as another area of the code. Okay, guys, I hope this is really makes sense right now when you see the array, how it starts. So the first element in the array will go in this area. Okay, the second element is gonna here. It's gonna third element here, fourth element here, fifth element here. The number 6 element is here. Okay, in the example that I wanted to show you guys, I wanted to print out, you know, specifically 7. Okay, 7 is part of the previous array, n-1 exactly. So this is what I wanted to show you in the array. So here buffer 10 equal buffer 10 in here is equal to buffer 0. So if the attacker added here 11 character, it will be overwriting buffer 1. Okay, if I know that buffer 1 is 5 characters, okay, I can overwrite the 4th characters here. If I manage to really add more things here to cover all buffer 1 and all buffer 2, and even to really override the return address here, okay, this does mean that my function here will never go back to the main function. If I manage to return address to another area of the code where I have added my code, then I can really execute something I want as an attacker. And how he do this, again, guys, I will show you. He is doing a wild guess. Or if he has your own application, he can try to decompile and do the assembly for your application and see how your application memory allocated, and then he will write specifically code for it. Okay, so he do something called reverse engineering. Maybe we talked about reverse engineering before, but how the attacker will do this, and this is the answer for Nawar that's question. The answer for Nawar question is either he is having a wild guess how your location is done, and he is trying to really target the return address here to be going to another area of the code where he has his own code, okay? Or he will disassemble and he decompile your application from AXEs all the way to see how you wrote your programs, and how and he will run this program and see how it's been filling the memory, and accordingly he will write his own exploitation. So again, let's just move a little bit here, guys. As I mentioned, the most important thing for the attacker here is to override the return address. He doesn't care about buffer one. If he even corrupt buffer one, is not a big deal. It's not gonna give him anything. The most important area for him is to modify the return address, because modifying the return address will allow him to modify the how the program is done, or how the program is executed. Because as I mentioned here, guys, the program will be executed, the main will be executed, this variable will be executed, and then we will call the function will do something, and then once the function finish here, it should return back to the main next instruction, okay? The attacker is really interesting to change the return address. Why? Because if he managed to change the return address, your program now will not follow the normal procedure and will not go to the main function again. He will go to another area of the code that he can control. Okay, guys? So this is the return address. So what the attacker will do, guys, again, he started to really see how many bytes between him and the return address. So he said, okay, you know what? This is 10, okay? And this is 5, and this is 4. Okay, so between me and the return address is basically 19 address, okay? So I wanted really to change the return address after 19 bytes. So I will inject 19 bytes of crab, okay? And then in the return address, I will override this address with another area, which is arbitrary location. And this arbitrary location is basically a location that attackers have a control over, and it will execute his code. So he will count this 19, and he will add crab until we reach 19. And then when we reach 19, the return address is basically saying, you know what, go back to this area of the code. No, I will change this to something, I want. So this is where he wanted to add his new address here. Okay, so in the next step, guys, if you can see, okay, this is where the attacker will add his code pointer. And what we mean by code pointer means it's something to point where in the memory I can find the code for the attacker. So we have here a pointer. A pointer means I'm gonna, show you where you're gonna go. Don't go to the main function again. I'm gonna tell you. Okay, so the attacker will write something here. It will point to another area. Maybe this another area in the stack, or maybe he will add it in the heap. But usually he added in the stack. So now let's see the buffer overflow can skip an instruction. We see how an attacker can use this executable, his own code, exploit the code. So if we jump one more slides here, guys. Okay. So we can see the attacker is started with adding buffer address until he reached to this buffer address, and then this is all basically he's adding where the instruction should be going. Why he's doing this? Yes. Just give me 1 second. Just 1 second. Okay, so it's gonna add buffer address. Why? Because he's overwriting everything here, because he doesn't really know where your return address is. So he's just filling this with a buffer address that he wanted your code to go to. And that's again what I told you. If the attacker really doesn't know how to really reverse engineer your application, because he doesn't have the source code, okay, so he will just add the crab here, buffer address, and all of them are gonna execute it to another area in the code, okay, where it's owned by the attacker. And the buffer address does have what? Does have the exploit code that's being injected by the attacker. So in both buffers, he will add buffer address because he doesn't know where is exactly. In the return address, he will add the buffer address. Even the parameters for the functions, he will overwrite it with a buffer address. So even when the return address now is going to be executed, okay, it's going to take you to this area called buffer address. What is exists in this buffer address is the exploitation of the code. Okay, guys, why the attacker doing this? Because the attacker maybe doesn't really know that there is 19 byte until the byte address, or he doesn't really know where is the return address. So he just keep, adding similar, sometimes we call it knobs, and knobs is gonna basically don't do anything until you reach to the return address, and say in the return address, go to this area. You go to this area, this is where the exploitation code. Okay, guys? I know this is, and the first time you read this, it's gonna be like really not easy to grasp. But again, we have explained, and just let me recap this quickly. We have explained how the buffers are really added here and loaded in the memory. Okay, we mentioned that every buffer or every array does have certain spaces. Okay, but again, C and C+ does not do any bound checking. So when you don't do bound checking and the programmer doesn't do any bound checking, so he can write in another area, he can fill this buffer with another code that can override the buffer above, but he doesn't really care about the buffer above or the frame pointer. He doesn't care. He wanted to really override the return address. He will overwrite it with an address that has his exploitation or he codes he wanted to exploit it. Usually we call it the shell code. So what the attacker will do, guys, he will keep trying to reach this. If he can really know where exactly it is, he will try to override the return address with arbitrary location. Okay, what is the arbitrary location? It's gonna be doing this, guys. The attacker code pointer will move to the attacker location where he has the code. And again, once I override the return address, when we try to execute this guy to go back to the main function, basically your processor will do this. It will not execute and go to the main function. It will be executed and going to this PA. The PA has the exploitation code. The exploitation code can give the attacker access to your, basically your files or access to a shell or a command shell. And that's why we called it the command shell. Okay. How do the attacker will do this, guys? He will basically, I would say, write something like this. This is basically another example I was going to explain. So he's gonna do something like this. Okay, he will fill. He will fill the memory space here for the I would say the buffer with all this stuff. What is this stuff in here? This is basically the binary data that he wanted to fill. And finally, by the end, okay, this is all is gonna overwrite all the way up until it reaches to the area that he wanted to execute, which is bin.sh. Once he reached to this bin.sh and executed, it will really, execute his terminal, and this terminal will be giving back to the attacker. Okay, guys? So if you guys allow me to show you how this is happening, we have a large string. We'll add this shell code here. This shell code will override these areas in the code until it will override the return address. When it will override the return address, it will cause this code to be executed. Okay, so here we tried to copy, string copy, this large string that he created, okay, to a small string that is exists in this buffer, which is 48. For sure, if you add 128 large string and start copy this large string to a buffer, it will overload it. So how it will gonna overload it? It will overload it with BA, which is the buffer code address. When that we reach to the BA and it override the return address with BA, it will go back to the BA. Where is the BA? Is basically the shell code, and it will execute the shell code. So this is another way that str copy will do. Okay, I have a long address. I'm saving it in the buffer. So in this long address, there is a lot of addresses that's gonna override the buffer until I reach to the return address. It will be changed with the BA. So your code now, instead of really jumping back to the main function, so your code here was gonna be returning back to the main function, which was the right thing. You overwrite your code with basically with the BA address. The BA address is now is what the attacker has already injected in the early beginning, and the shell code will be executed. Okay, once the shell code is being executed, guys, then it will give the attacker the command line he wants. So this is how it works. Okay, guys, this is a small program how it works, and eventually it will give him the bash running in his computer. Okay, guys, so this is very easy way. One of the earliest attacks that's happened in the buffer overflow was some attack, a worm called Code Red, and this is happened in 13th of July, and this basically impacted Microsoft IIS, which is web application. So someone managed to really infect web application, which is running a server called IIS with this code red. And this code red was really basically exploiting this buffer overflow. And this is the diagram here. It shows you how many computers or web servers has been impacted by this. It was almost, I would say, 300,000 okay, web servers around the globe, and this is, around the globe, and that's 2001 was a big number, infected by anyone who was running IIS certain version. It was exploited by this worm, and what happened is when this worm exploit your machine, what it will do, it will give you something like this. It's basically, this is the code string. It's something similar to what I have shown you guys, okay, before. So this is a get command, and this get command will be sent to your web server. Your web server is an IIS, which is basically a web server for Microsoft. It will cause a buffer overflow because this is going to be all like an overflow. And then when it execute, it will execute this part of the code. And this part of the code will change your main HTTP or your main page to this. Welcome to the worm.com hacked by the Chinese. Okay, so this is an interesting part of the attacks. The rest of the lecture, guys, I have added some, I would say, how the address space is managed and how it works, and how if you have some memory location wanted to add, how it's being pushed, and how something called stat pointer will be keeping, pointing to a certain point in the in your memory. So, for example, if I have 3 registers here or 3 different variables, and I wanted to put every time I'm putting one of these variables here, the stack pointer will be moving from the early space in address, and he's moving to another area. And when you push more and more, it started to change the location. Okay, if you really later on, because all our data is being pushed at a certain time and then being popped again when we done using the programs. So the stack pointer is always going up and down in our stack. And again, what is a stack? Is part of the system memory, which is really concerned about your function and your local function variables inside. And that is exactly what the attacks was all about. Okay, this is again what is a buffer overflow, and again what is string copy is all about, and how string copy is working. Okay, and then how to find buffer overflow. Okay, so one of the techniques is fuzzing. Basically, you send a lot of data to your web application or to your application and see how your application will react. So this is a techniques. And this is our, in the end of the lecture, is saying preventing buffer overflow. So this is the buffer overflow, like a really, I would say a brief way, but if you wanted really to get deeper in buffer overflow, you should be using a compiler and decompiler to really look at the codes and try to understand where is your variable are saved and what is the memory addresses for this. This is can be done in a maybe more advanced course. Okay, guys? I'm sorry that we didn't really take a break until now, but I thought it's good to just finish the whole topic as much as we can. Again, don't take it like really serious all of the beginning. Just look at the topic in an easy way, and then take it gradually until we reach to the end of the program. Okay, guys? Okay. I will give you guys around 25 minutes break. And then when you go back, Abir will be explaining one of the labs. Okay. So I'll see you guys inshallah in 25 minutes. So we come back around 11, 10. Okay. When we come back, inshallah, we'll be looking at one of the labs today, inshallah. Have a great day, guys.